Hi, and welcome to the video on reading frequency histograms and polygons. By the end of this video, you should be able to interpret what a frequency distribution histogram and polygon is and how to work out some answers to some questions. Again, here's what a frequency histogram looks like and a polygon. The histogram looks like a column graph with no gaps in between it. That's because we've collected numerical data, and that's what our independent variables are going to be on our horizontal axis. The frequency polygon is similar to a histogram, except that we put dots in the middle of our columns and we join them up to create a shape or a polygon, hence the name. This is just an example of a frequency histogram and polygon on the same graph. So let's take a look at some questions. The results of some end-of-year tests are shown for 4 different classes in 4 different histograms. What I'm going to do is I'm going to ask some questions and I'm going to get you to pause and consider your answer before moving on. The first question is, what were the tests out of? Pause and consider your answer by looking at the graphs. Okay. If you look at the horizontal axis, it tells you what the scores will go up to. They range from scores from 0 all the way up to 50. Each column represents a group of scores. So everything from 0 to 9 is in the first column, and everything from 40 to 50 is in the last column. So these tests were all out of 50. How many students were in each class? Pause and consider your answer. Okay. If you take a look at the frequency, that will give you an indication of how many students are going to be in each class. We need to read off the columns in order to work out how many students there are in each particular class. So let's look at class number 1. If we were to read off the columns and add up the totals, we could see that there were 25 students in the class. Looking at class 2 and reading off the frequencies, we can see that there are 5 students in each of the groups, and there are 5 groups, so 5 lots of 5 is also 25. If we look at class 3, we can see that the frequency goes up to 18, which is huge for this middle column, but they're very small in the columns on either side. So if we add up all of those columns, we get 25 as well. Finally, looking at the last class, which also has a frequency that goes up into the 20s, but doesn't quite reach there, if we added up all their totals, we would see that there were actually 26 in that class. Next question. Which class has the highest overall score? Pause and consider your answer by looking at the graphs. Okay. We want to work out what the highest overall score is, but we don't have individual scores in order to work it out, so we have to work it out by the groups that they give us in the classes. If I look at class 4, I see that a large number of my students scored in this higher range. In fact, 20 out of the 26 students scored between 30 and 50. These other scores are all distributed equally amongst the lower end, and here there's a higher group in the middle, as same as with class 3. So class 4 is going to have the highest overall score. Which class do you think would be the easiest to teach and why? Pause and consider your answer. Okay, so what makes a class easy to teach or hard to teach depends on a lot of things, but looking at the data in these graphs, what we would consider an easy class to teach is one that has a lot of students roughly at the same level. If we look at class 4, they do have a high number of students achieving well, but they're also tightly grouped in that top range. There are only a few students who are at the lower end, so this class would be a lot easier to teach than someone that is, say, some class that is distributed across a lot of different groups. If we look at class 3, we have a similar case. We have a large proportion of students who are here in the middle, whereas there's only a few at the top and a few down the bottom. This would also be a reasonably easy class to teach when you only consider the data. Okay, the idea is that it's easier to teach students of like abilities. So which class do you think would be the hardest to teach and why? Pause and consider your answer. Okay, well, if it's easy to teach students that have like abilities and they all score roughly the same, this means that it would be harder to teach students where they are ranged throughout all the scores. And that's class 2. Class 2 is distributed evenly from the lower end all the way up to the higher end. What makes a class like this difficult to teach is that you would have to be differentiating for every student in that class, which means that there's going to be 5 groups of activities that you would have to have for each of your classes. Class 1 looks pretty similar, except they are fairly grouped towards the top here, and it does make it a little bit easier when you're grouping the information in that respect. But for this answer, we're looking at class 2, because they have many different abilities in that class. Which class has the highest median? Now, in order to answer this question, you need to know what a median is, and I haven't covered it in any of our videos yet. A median is the middle score when all the scores are put into order from smallest to biggest. So each class has 25 students, so the median would be the score that comes in at about the 12th or 13th score. So let's take a look at class 1. Class 1, the 13th score would be here in the 20 to 29 range because we have 3 scores so far in the early ranges, in the early classes, and then 10 in the middle. So altogether there's 13 there, the 13th would be in the middle. For class 2, we have 5 and then 10 students in the first 2 columns, but we're looking for the 12th or 13th, which means that we need to go to the 3rd column in order to find the 13th score. So again, the 20 to 29th score is our median group. Looking at class 3, again we're looking for the 12th or 13th student. Now there's only 4 students happening so far in the early stages, but when we get to the 3rd group of the 20 to 29, we can see that the 13th student would be here in this column. Finally, looking at class 4, looking for the 13th student, we can see that we have 1 student here, then another, so that's 2, and then 4 more, that's 6, and then if we add another 9, the 13th student will be here, because I know that if I add 9 to 16, I have 15. So the 15th student is here, which means that the 12th and 13th is also here. So the class that has the highest median would be class 4. And that's it. That's just a few questions that you might be asked from some frequency distribution histograms and polygons. It's important to note what the scores are whenever you read a graph like this, and what the frequency is and what scale they've used, and that helps you to read the graph. Good luck, and ask any questions as always if you need it.